Welcome back to the channel, everyone. And this is my space where we talk about industrial automation, PLC programming, and real project experiences from the field. In today's video, I want to share a case from one of my recent projects. It's a situation that many automation engineers will eventually face. The production line is running, the machines are operating continuously, and stopping the PLC is absolutely not an option. However, I still needed to establish communication between two Siemens PLCs so they could exchange data in real time. Normally, when we make program changes or add communication logic, we stop the PLC first to avoid risks. But in this case, the process could not be interrupted. The solution I chose was to use the TSEND and TRCV instructions, Siemens communication functions that allow data transfer without taking the PLC offline. The first step was to ensure that both PLCs were connected on the same network. Their IP addresses needed to be in the same segment, and they had to be reachable from each other. Once the network was confirmed, I opened Tier Portal and went straight to the main OB. From the instruction library, I navigated to Communication, selected Open User Communication, and inserted the TSEND instruction into the PLC that would act as the sender. Inside the configuration of TSEND, I selected the partner PLC, which would be the receiver, and created a new connection for both local and partner devices. For the REQ input, I used a 2 Hz clock pulse so the data would be sent continuously. Next, I created a new data block to hold the values that I wanted to send. I disabled optimized block access to make communication more stable, especially since we would be referencing fixed addresses. I structured the data as 2 bool values, 1 int, and 1 real. This was just an example. In real applications, the structure can be adjusted based on project requirements. After compiling the data block, I assigned it to the TSEND data parameter. To control what data gets sent, I used M10.1 to trigger the first bool, and M10.2 to trigger the second bool. I also applied move instructions to send values for int and real types, using MW100 for the integer and MD102 for the real number. After compiling, the sender side was ready. I then moved to the receiving PLC. Again, I opened the main block, went to the communication section, and inserted the TRCV instruction. In the configuration window, I selected the sender PLC as the partner and chose the same connection profile created earlier. I then created another data block for the receiving side. The structure was made identical to the one in the sending PLC, 2 bools, 1 int, and 1 real. Optimized block access was disabled to match the sender configuration. After compiling, I assigned this data block to the data parameter of the TRCV instruction. The program now had a complete communication path. To test the system, I used S7 PLC SIM Advanced to simulate 2 PLCs. I started both virtual controllers, downloaded the programs, and, this was the key part, the downloads were successfully applied without putting the PLCs into stop mode. This meant the solution was compatible with live machines, just as required by the project conditions. During runtime monitoring, I first activated M10.1 on the sender. The data did not arrive yet because the TRCV instruction needed to be enabled. So I set N_R to 1, downloaded that small change, and tried again. This time, as soon as I activated M10.1, the corresponding bool value on the receiving PLC changed to true. I repeated this test with M10.2, and the second bool value was also received correctly. Both data blocks, sender and receiver, reflected the changes almost simultaneously. Then I tested the integer value. I set send_int to 123 and watched as the receiving PLC updated instantly. The response was fast and accurate. Next, I tried sending a real value. I entered 45.6, and the receiving PLC showed exactly 45.6, without any rounding or value loss. When I deactivated M10.1 and M10.2, the bool values on the receiving side went back to false, following the sender logic perfectly. I repeated several tests, and the communication remained stable every time. This real-time communication using TSEND and TRCV proved to be reliable, fast, and most importantly, it worked without stopping the PLC. For industrial environments where downtime is costly or impossible, this method is incredibly valuable. With the right configuration, we can transfer bool, int, real, or even more complex data structures safely while the machine keeps running. If you found this experience helpful or relevant to your own automation projects, feel free to like this video. If you want to support the growth of this channel, subscribe and turn on the notification bell so you do not miss the next upload.